So about Kano model. Do you know what is Kano model just now? This is what I'm explaining. Exciting needs and basic needs. I've give you example about car in 1980s, which is basic. I still remember, instead of fabric lining, they use polymer PU, and under the lining they put fiber, coconut fiber, and spring. So you imagine how struggle we were. And now modern car they put leather and PU4, so much comfortable. So that time was a basic need. So car with air condition, that's exciting. And today, as we discussed this morning, basic need of a car at least 360 camera, VSC, ABS is compulsory. It's a basic. You know, in 1980s, seat belt also not available in the car, not installed. Seat belt. So they started to introduce seat belt in 1985. So at one time, seat belt considered excitement needs. So today, what is excitement need for a car? What is excitement need? Very hard. Probably whatever available on Tesla can be the excitement need now. For example, autonomous vehicle. But after we have that, what is excitement need? We don't know. So that is a difficulty for a company who wants to introduce new product to the customer. So that's why it is easy for us if we could segmentize the customer. For example, iPhone for professional, working professional. So perhaps after I retire, I'm not going to use Apple product anymore. Because especially I don't mind. Probably I will not go. I will not bring laptop if I go anywhere. I just small Nokia phone. Then so we need to know the segment, the needs of the customer when we talk about quality, what we want to give to the customer. And another thing that we want to identify what customer really need, we can use quality function deployment, QFD. Some people call it need house of quality. If you involve with the Lean Six Sigma or perhaps Kaizen team, or if you want to show to the auditor for ISO 9001, it is good if you could show this house of quality, because you know already what your customer is expecting from you. So this is the element, these are the elements that we have in the house of quality. We start from the customer requirement. How could we get customer requirement? The information about customer needs. How do we get it?
From surveys.
Survey, that's the traditional way.
AI.
But now you use AI. Perhaps we can just ask ChatGPT. For example, can you ask ChatGPT about airline passenger requirement? List me airline passenger requirement. How do you answer that? Perhaps in the Google also there, actually in the Google also they have, but we need to read through and then find out by our own. But if we ask ChatGPT, it will give us
10 points.
10 points. Okay. Read for me, please.
Ticket reservation,
Ticket reservation,
valid identification,
identification,
visa and entry requirement, check-in, baggage allowance, security screening, boarding pass, health and vaccination requirement.
Okay, that is the requirement for the passenger. But as a passenger, what is your needs from the airline? Can you ask further?
Expectation.
Yeah, what is your expectation from the airline? Give me 4. Tell ChatGPT, give me 4. And they will give you 4.
Expectation from users.
From customer or passenger from the airline. Expectation of passenger from the airline.
Safety and security.
Safety and security, reliability and functionality,
quality of service.
quality of service,
Fair pricing and transparency.
fair pricing and
Transparent fees.
transparent fee. Are you agree with that?
Yeah.
Cool. So very easy now.
Yeah.
You can simply ask ChatGPT. So we put it here, customer requirement. Okay. This is example for restaurant. So yours is the airline. And then technical requirement. Can you ask ChatGPT what is the technical or technical sometimes it might confuse. Can you ask ChatGPT what are the functional requirement of airline? Can you ask that? Whether they can give you correct answer or not? Functional requirement. Or functional facility, something like that, or facility. You confused?
Just package it.
Huh?
Reservation booking system.
Okay, reservation booking system. Can that one can be put here.
Flight operation.
Flight operation, mobile apps,
Service.
customer service, and blah blah blah. Eh? So we can just simply ask the AI instead of we doing the survey. But traditionally, if you want to get the technical requirement, you can ask the regulator. For example, for airline, what are the regulator for airline? Probably those who are doing ranking for star ranking for the airline now, Qatar X #1, so we can check from their ranking assessment tool so that we know what is the requirement. And about this example, the technical requirement or functional requirement, they ask the municipal because they are giving license. So what are the requirements for a restaurant? So they give the requirement. But if we really follow what they are giving, maybe too many. So we have to identify which one are important and perhaps practical for us. Not necessarily we follow all. So this is the example what I want to share with you for customer requirement for a restaurant: clean facility, comfortable seating, delicious food, and server. Server is very important, especially in Malaysia. I don't know in Pakistan, but in Malaysia, Malaysian, especially those who are living in Klang Valley, they would like to go to in a mamak restaurant. But if you go to East Coast, they don't like mamak restaurant, they go to a Malay restaurant. Why mamak restaurant? Because of the responsive server and delicious food. Because we want express, all the time express in Malaysia. Even eat also we don't want quick. Suddenly we feel full. In Japanese they call it mo ipai. Okay. This technical requirement we got from the municipal council or the PKL or something because they are giving license. This is among top top 5 requirement: type of tile, the existence of the floor tile because they want to see the cleanliness, seat material, server training, and menu standardization is very important. So now you want to see the purpose of this QFD because you want to, it will help us decision. Just to help us making decision, but not giving us absolute decision. Just give guideline, idea for us, what should we focus. And after we know this, we need to ask ourselves whether we can afford to do it or not. Because everything is related to cost. Not necessarily whatever they tell from this QFD we follow. Because sometimes we can afford to have that. So we have to discuss with our partner, board of director. For example, this restaurant, if Pelita restaurant, they have board of director, so they will meet in the board of director meeting. But for small restaurant, you have to think whether I have money to invest or not. So you will see after this, maybe that shows the importance, but for you it's not priority because you have your own reason. So we put like this, and then we do the weightage, most of the students will ask me, how do I put 9, 3 and 1? Actually, any number, but the purpose of weightage is to see the difference. If you like to put 50, it's okay, as long as there is a distance between these three scoring. So I put 1, 3 and 9. So then I ask my team about the interrelationship. So I cannot do by my own. So I call team, get brainstorming. For example, for this restaurant, I got feedback from my probably focus group, customer. I call 2, 3 of customer. Then of course I have to pay the customer, my employees and my partner. They ask clean facility and type of time. Is it strong relation or no? Okay, clean, time, relate. Sometimes you see not clean, but it is clean, but look like dirty. You understand what I mean? Type of time, because it is so rough, so dirt will fix on the tile, so it's not look clean. And then dirt resistance of the floor tile, definitely strong associate, 9. We put 9 here. Seat material and clean facility. If the seat material easy to clean and so on. If you imagine some restaurant you go, the seating, the fabric of the seating was made from light color, white or light yellow. So you see not clean. Or perhaps if they use kind of plastic and easy to clean, so it's depend on the material as well. Server training is not related, very weak. Server training, it is related but very weak. For example, if the server is particular about cleanliness, they will clean the restaurant more often. So you put 1, and menu not related with the facility. Seating and type of tile not related. Dirt resistant and seating not related. But it is related is the comfortable seating. So material related to the comfortable seating, we put 9, and these two not related. Delicious food, this one not related to this, but weak related to server training. Why? Because maybe server can suggest us what kind of food we can put the combination so that it becomes delicious. Menu standardization is important. Yesterday you also tell me that when you go to hotel, sometimes the combination of menu not good, not suitable, so you feel the food is not delicious. So this one is important. We put 9. Responsive server. This is the reason why we eat in the Mama restaurant. Server training is very important. You sit and then they know already what you want to eat. You don't have to speak. Do you notice sometimes? Biasa. Okay. Body language nanti. Body language. Okay. Okay. 9. And menu standardization also 3. Because good server, they know how to put the curry, put a mixture of curry for your nasi kandar. Okay. This is how we make the relationship between customer requirement and technical requirement. Then after that, we do the analysis for the technical requirement to technical requirement. Because we want to see the association. We put a intercorrelation here, positive and strong positive, negative and strong negative. For example, type of tile to the dirt resistant, strong positive, +9. Type of tile to seat material, negative, -3, negative only. Type of tile to other thing, menu is not related, dirt resistant, not related to others. Seat material not related to these two. Server training is strongly related to the menu standardization. This is on the technical requirement or on the functional requirement. So from the airline, just now you got the list from the ChatGPT. You can try to have this kind of intercorrelation. Then after that, we do benchmarking. So in the QFD, besides we do the analysis interrelationship of customer requirement and technical requirement, we do also the benchmarking. So this case, this restaurant, they have chosen two restaurants that they benchmark probably the best practice. So in your business, you have to find out who are your best player. Housing development, who are the best player in Malaysia? EcoWorld, IGM, which one is?
Sundarbi, Sunway, UEM.
Because I'm teaching project quality management as well. When I teach this one, because that class they have final exam, usually every semester I will ask this question, this QFD in the final exam. Then when we construct this and when we discuss about the benchmark for the housing developers, they said EcoWorld. I don't know why EcoWorld.
Because the famous one.
Famous one.
Yeah.
But the house also expensive.
Yeah.
Expensive.
Itu quality.
So for your business, you have to benchmark. For example, oil and gas. So who should you benchmark? Petronas, who you benchmark?
Petronas, Shell,
Or you benchmark with Shell?
yeah, Exxon,
Exxon. Okay, Shell, who you benchmark?
Petronas.
We will say industry benchmark.
Industry benchmark.
There's industry benchmark, and internally we also have our own benchmark to meet. Normally we call it the top quartile or best in class.
Best in class. Who is the best in class?
From the industry, from the industry, we subscribe to the benchmark company. I think somewhere in Europe or US.
Oh, they will do the benchmark.
Yeah, they will do the benchmark.
Okay. So from the benchmarking, we know that we put our benchmark, sure, and then we analyze, we evaluate the benchmark. We benchmark based on this requirement because we want to know where is our position. Where is our position? Us is this company position, and they're comparing with company A and company B. For clean facility, this is like a scale 1 to 5. 1 is the poorest, 5 is the best. Like a scale. So they put themselves as 3 for clean facility. Company B 4 and company A 5. So this company A consider elite like Q Bistro or what else. There is one Mamak restaurant selling biryani in the bamboo hill, you know, next to the highway. The price of one plate biryani around 38 ringgit. It's around 1,200 yen. It's okay, cheap. In Japan, 1,200 yen, it's okay, normal dish. But in Malaysia, oh, expensive, 38 ringgit. Yeah, because our meal just cost us 7 ringgit. You know how much they pay for the rental? Guess, just guess. How much they pay for the rental? They deal with the owner of the area, of the land. The rental comes from percentage of revenue per month. So that guy happened to be friend of my friend, also lecturer here, friend of your lecturer here, you can guess who. Schoolmate, this schoolmate. He paid to the owner of the land 100,000 per month. So you guess how much is the income at least per month? 1 million.
The revenue.
The revenue 1 million, and he said he pay for the utility and so on, and then he put aside for the investment because to get the ROI around 300,000. So around 400,000 is the capex. So including the salary, 400,000 for the capex, the rest for himself. And he have couple of restaurants in Malaysia, another 2-3 restaurant. I think also the elite restaurant. So for that one, I think the cleaning facility might be fine because the meat is very expensive. Otherwise, we'll go to the Bismillah, Bismillah restaurant. Okay. Sitting, for this one, they put 4 for themselves. A for the company A, 3, and 5 for company B. Delicious food, they claim theirs at 4, scale 4. Company A, scale 5, but company B, scale 2. Server, theirs at 4, A for 5 for A and 3 for B. This is how they rank using Likert scale for the benchmark. After they have done this, importance. The importance means this is a weightage as well. You can choose any number just to show the weightage. But in order to have this, they need to get agreement with the shareholders. Which one is more important to us? Or perhaps you can ask the customer. Or if they use survey, they can check on the frequency from the survey. They can use the frequency analysis. Okay. Referring to the airline that you have just now, you asked the ChatGPT about the customer requirement on the airline. They given you 4. Can you ask back? Out of 4, can you rank me based on the priority? Can you rank me based on priority? So they will rank for you. Now easy, everything AI.
Yeah.
So next year your faculty also change to AI faculty. Yeah, AI faculty. You no longer Razak faculty.
ChatGPT.
Name Razak is not.
No.
Razak also replaced.
Maybe all the courses by default. The parent one, parent name.
The parent also. The rest remain the same.
But at we have something called Cairo.
Cairo is over there. That's a center of excellence for AI.
That's not the one.
That's not the faculty. That's the center of excellence. But Cairo also associate to this faculty. Okay, what is the ranking?
If you rank safety and security is the first.
Safety, security,
Second is flight operation.
flight operation,
Third is reservation and booking.
reservation and booking,
Fourth is check-in and boarding.
check-in, boarding. There's 4, right? So got 8. Okay, no problem. But initially, we should ask tell ChatGPT rank 4, list 4. Okay, because the more we have, the more headache we have.
Okay.
So just 4 or 5, and then after that, immediately we ask them, can you rank for me? Then you can ask for this, and then can you suggest me who are the best player in the business, and then they will tell you. So you can use to put it here. So I go back to here, ranking. Clean facility they put 9 because the frequency from the survey shows that's the highest frequency. Second is delicious food, they put 8. Responsible 7 and comfortable sitting 6. But in Kuala Lumpur, which one is your priority?
Facilities, comfortable sitting, delicious food,
Number 1 for you here.
clean.
Clean, clean. So if clean, you are not going to go to
Mama.
yeah, Mama. Clean.
Mama clean.
For example, the Bamboo Hill one or Q Bistro. You know Q Bistro? It's a high-end Mama restaurant. But less clean one, you can go to Kudu Bay Abdul, Jalan Tar, you know, Kudu Bay Abdul, or Yasin. Yasin, okay. But Insaf, if you go to Insaf,
Oh, you some?
you Insaf already. But the customer is still full, right? Although the price is expensive.
Yeah, because the brandy.
The brandy.
Yeah.
Is it tasty?
Yes, very
Tasty.
delicious.
I tried there 3 times.
Huh?
Price okay, expensive. I think yeah, tasty. The tea also tasty. But
Insaf, Jalan Tar.
Terlentar. But is there any competitor better than Insaf in terms of value?
I don't think so.
I think so. How
Okay,
about
I
Insaf?
was my parents bring me to the Insaf when I was very little. You know, I think 9 years old.
9 years old. So
Yeah.
until today.
Until today, I don't know. Something wrong
You
with this
never
app.
eat some, huh?
Never eat some.
This quite long, huh?
Ah. Okay, we go back here. So after we have done the importance, ranking, then the target value. This come from this Likert scale. So we compare with the benchmark target value. Currently you are at 3. So discuss with your shareholder. You want to remain at 3 or you want to improve? In this case, you want to remain at 3. Why? Maybe because you think that he cannot improve. For the cleanly, we think that okay, we are clean enough. Okay, if we want to more cleaner, we have to invest. So they can afford to improve. Okay. Comfortable sitting. Currently there are 4, so they said, okay, we can spend money, change the chair and table. Okay, so they put 5 target. Delicious food. They said, oh, ours better. Okay, no problem. Chef, we imported chef from India, so good. So 4. Responsible, they want to remain at 4. See, okay. So as you see here, they only want to improve on the comfortable sitting. It's okay. That is what they have agreed. And then sale point. This is from the survey also. 2 means give higher sale point, 1 lower sale point. This is also weighted. You can decide by your own what number you want, as long as it shows the different. So they know that delicious food and responsible will give higher sale point, but sitting and cleanliness is not really important. Then after that, they multiply all these 3. 9, 3, 1, 27, 5, 6, 1, 30, and so forth. They got the absolute weight. That's why I said, and you can put any number as long as it shows the weightage. As long as a distance between number, it's okay. So from here it shows that delicious food followed by responsive server is important. From this one. And after this, they do this absolute weight competitive assessment for the technical requirement. Same assessment like we did for the customer requirement. So after they have done this, they calculate the absolute weight for this interrelationship. For example, how they got 81, 9 multiplied by 9, they got 27 multiplied by 9, they got 81. Sorry. 9 multiplied by 9, they got 81. Then 9 multiplied by 9, 81. 3 multiplied by 9 plus 9 multiplied by 6, they got 81 also. 1 multiplied by 9 plus 1 multiplied by 8 plus 9 multiplied by 7, they got 93. This is the absolute weight. They multiply by this interrelationship with the importance. Importance means from the survey, or they ask AI to provide the result from the ranking. Just now we have ranked that. So it shows the customer needs. What customer said it is important. They forget about the target. This is the target. The target maybe is whether they can afford or not. But this is what customer really want. So you know, we got the absolute weight. So from here we know that menu standardization is important for a restaurant, followed by these 3. Cleanliness. But the first one is menu standardization. So this is in line with the delicious food expected by customer. So from here, they can imagine, you can have in their mind what they should do to improve the restaurant. And then on the relative weight, absolute weight 27 multiplied by all this interrelationship, they got this. So from here also shows menu and server is important. So now we have done this QFD. Factor is okay, just divide by the sum and then you have the factor. But from here also we can make a decision. So what is your decision? What you want to do as restaurant owner?
The one is relative weight. Relative weight.
You have this
Okay.
to guide you for the technical requirement. You have this to guide you on the customer requirement. So now you want to improve this restaurant. So what you want to suggest? Let's say you are consultant.
But we have a relative weight before down there, right?
This is multiplied with the
Oh.
absolute weight.
Okay. So the higher is
So which one you want to do? Because absolute weight important by the customer and the interrelationship. Relative multiply by absolute weight also related to all this, including benchmarking, and then with the interrelationship. So you can refer to both actually. So
Excuse me, doctor.
Yeah.
How do we get the value of 744 at the relative weight?
744. This one? Okay. This one multiply by 64
Absolutely.
plus 3 multiplied by 56. Got 744.
If 93, just 9 times 60.
93. This one
in the slide different.
9 times 8 plus 3 times 7.
Or the highest of
This one. This one 9. 9 times 8.
only 8 the highest among the 8, 4 and 2.
This is your important. 9 times 8 plus 3 times 7. For the absolute weight, we are referring to this importance. Importance ranking. Just now, we also asked ChatGPT to rank for us. The highest rank will be we got the highest weightage for importance.
QFD.
I think so.
You can
Even in the
Tablet ni.
internet also, they have template for this.
quality function deployment.
Oh, it's like
Besides, you can use this to improve your company. You can use this for your consultation work. Initially, there are a lot of work to do for the, as a consultant because you have to do the survey and so on. But now you can just ask. Then you produce report can show this is what the customer wants.
Does it mean the highest one we need to prioritize first? The relative weight?
Yes. So, what's your decision?
so maintain the menu.
Many standardization.
Yeah.
Standardization.
You know? Okay, you look at here. This is given higher score, and here give higher score. Server
Yeah. We have to maintain our menu and be quick in serve.
quick serve,
Yeah.
improve your service.
Service, yeah.
So, how about your target value? You want to improve on the setting only. So, you have to improve. You have to change your target value.
So don't change now.
But
Change we needed.
whether you can afford it or not. Okay, you know that now many strategies is important, server training is important. Probably you can use internal training to build up the capability of your server. But can you afford to have delicious food? Probably you need to get a new chef. That one, that's why I said when we do the QFD, there is no right or wrong answer. This QFD just suggests, just help us to make a decision. But this is not absolute. You have to ask yourself and discuss in your meeting, okay, this is what TLB says, so how about you want to follow TLB or you can afford to follow this, so which one we should do first? Okay, this is about, any question? Yeah.
Sorry doctor, I'm not clear for the 9687, right? Just now you see from ChatGPT we asked 4 factors, right?
What is one?
Yeah, 9687 is called.
9687.
Yeah, for
Okay.
the importance.
Yeah.
So if it's the 4 factors,
4 factor.
we
Okay.
ask ChatGPT. But what about the weightage? Meaning if it's
The weightage you have to put by your own because we want to know the number, highest, medium, low.
so can we ask them to rank it by like out of 10 maximum score? How
You
much?
can ask ChatGPT, they can do for you also. But actually, it's not really important because we have to put the highest number shows the highest importance. So it's up to you. What ChatGPT can do for you also.
Okay. The technical requirements, right? This one you say customer requirements. I assume we get from VOC, right? The technical requirements we will define ourselves. or-
It depends on the business. If for one restaurant, they got from the municipal who giving the license.
Do you give us technical requirements?
Yeah, yeah.
How
Can I,
about
can I add like parking space or anything in technical requirement?
Yeah, you can put if you like. But you need to ask whether it is related with the what customer requirement. Remember yesterday we discussed about symptom and function. So we have to be very careful because otherwise we investing for nothing. When we want to invest in our business, invest only that is related with the value. If not, doesn't add value. But it depends on your perception as well. For example, when I give that kind of opinion in my workplace, some people didn't agree because their dimension is different. My dimension, because I come from industry, from manufacturing, I always look on the function because money is important for me. Profit margin. For them, it's okay because we don't mind about cost. There are some researchers when I ask, okay, you want to do this, okay, you want to propose this to Petronas or whatever. How about the cost? Oh, the answer was, I don't talk about cost, but what important for us is the technology, is doing the mental characterization. No, they are not doing charity, they are doing business. What do you think? Whatever technology we want to put, but if it doesn't add value, no point to introduce the technology. This is conflicting in our country. For example, we want to use smart tag and RFID, for example. When you want to introduce RFID, why you use that silly RFID in our country? Why don't you just acquire technology that Singapore is using? Now Singapore using a satellite RFID instead of the rectangular RFID. Hong Kong also have the RFID in the highway. Why do we just adopt the technology? Why must we build? Actually they claim our RFID is much better than other country because it is directly connected to the internet. And then straight away goes to the touch and go server, and we deduct straight away your money. Unlike the RFID in Hong Kong and Singapore, they said it is not real time. Why they didn't use real time? Because it risks in terms of internet congestion. There are places where they cannot read your RFID. You have the balance there, but they delay or sometimes they cannot read, or you have to slow down very slow your car because internet congestion. Some places internet okay, no problem. But if you go to the LPT, you have problem there. Because I was told that the RFID system they use at the LPT is different than in Kuala Lumpur. Different system, different platform because of some reason. So that's a problem. When we want to choose the technology, we want to choose anything, We have to carefully study. Otherwise, it doesn't defeat the purpose. If you notice now, smart tech is much better than RFID. Smart tech. Previously, we thought that smart tech is useless. Anyway, the system that we are having now, we thought it is not good, but if you go abroad, you will notice that ours is better. The toll collection system. In Japan, they still use gantry like us. They didn't use camera RFID like Hong Kong and Singapore. They still use gantry. But they use a system similar to a smart tag or something. It's very efficient. In Kazakhstan, very funny, the driver have to stop. If the driver do not use card, they have to put a coin or cash into the machine. Very old school. Sometimes we thought that ours not good, but actually people are looking at our system better. There is an analogy. Actually, when I asked one ambassador when I was in Kazakhstan, he was the ambassador of Malaysia in Kazakhstan, but now he finished his term already. When I talk about career, ambassador career, okay, good, your career is better than me, you can work abroad, and government give you a lot of perks when you are abroad. And the answer was, okay, usually people we look on another field, or the grass and on that field is more greener than our grass. But when you go there, you will notice that your grass is greener than their grass. So it's happened to our people. It's just perception. Maybe you didn't agree with me, but this is what I was observing when I go abroad. Usually when I go abroad, I will start thinking that, oh, I'm lucky to be Malaysian. Even when I go to Japan, many times, every year I go to Japan. Initially when I go to Japan, I was so impressed. Wow, Japan very good. But now I have different perception. Because I can see the grass. My grass is better than their grass. Go to UK. Wow. UK, do you want to live in the country that every Friday evening there are drunk people on the road and speak with the dirty language, whether it is man or woman? And then sometime during weekend, there's a guy who sit in front of your door, drink beer, and tomorrow morning they just leave beer in front of your door. In Malaysia, it's peaceful and you are so privacy. So it depends, Depends. Even when we talk about tax, we say Malaysia tax expensive 17%, expensive. But in Japan, the tax is around 40%. In Europe, how many percent? About 50%?
Finland 60, right?
60%. You can compare their benefits because the tax they are paying so that they can afford to give more benefit. Similar to Kuala Lumpur. People said facility infrastructure in Putrajaya is much better. Every person they have their complex kejiranan. And then that complex kejiranan, neighborhood complex, in English, neighborhood complex, they equip with the gymnasium, with all the sport facility, with the swimming pool. Every person, and also they have good infrastructure. Your area, you are living in Wangsa Maju, you do not have that kind of facility. Kuala Lumpur. But how much they are paying for their quick rent? Expensive. That's why they got good facility. So we have to compare in a reasonable way actually when we want to make comparison. Many Malaysians especially, when I read from the social media, they keep comparing, but they did not live in that environment. They just compare. Oh, UK give free education. Yeah, free education. How much tax you have to pay? Sometimes you do not have child, but you have to pay high tax. Unfair for you, but you didn't get the benefit. Sometimes you have pay tax, especially you do not have child, and then you do not use the hospital. Hospital in UK is free under NHS. So in our country, we are quite lucky because we are paying what we are using. We use highway, we pay for the toll. Hospital, if you can afford medical card, you can go to the government hospital. Still, as Malaysian, you can still get the benefit. In this country, okay, tax still cheap.
Tax is cheap.
Not, it's unreasonable, 17% tax. While other country quite expensive. That's why our operating expenditure is high compared to our investment. Operating is high. That's not good indicator actually for the government. So that's why government think how to convince public to reduce the subsidy. Now next year they start to introduce tax for the online goods. You buy from the Shopee or Lazada, they will start charging you 10% tax for those price less than 500 ringgit. Okay, I'm not campaigning for the government, but I just give you realistic opinion. Okay, this is about quality function deployment. Then we go to SPC.
Doctor, for the QFD, is it applicable for human? For example, we have to change the human behavior to meet our expectation. Is it considered okay to use that QFD, or they have another prioritizations or evaluation metrics?
Actually, you can use in anything because it's related to the value. But I think it's unfair to use it for human because human is very subjective. For example, we want to evaluate the kindness. Kindness also subjective. Kind, I'm kind, you are not kind, subjective. Beauty, subjective. So this is my perspective, my opinion. We can use it, but it's not reasonable to use for human. Product, okay. Service, okay. Okay. Any question about QFD?
So what the best tools for humans
For human,
to evaluate their?
I have no answer for that. Because that's not my field. I'm not studying human, I'm studying quality. And I'm focusing on the robust quality. So I have no answer for that.
Can you check?
But relating to my observation about quality, my perception of quality is to improve quality to reduce cost. Always remember this. You want to improve quality. This is what Dr. David always said. Where's the market? This is what Dr. David always remind us. Quality. Cost. Quality. By right, from Dr. Deming idea and Dr. Juran, they agreed that we improve quality to reduce cost. Improve quality to reduce cost. Because while improving quality, we reduce the standard deviation. At the meantime, when we reduce standard deviation, also we put standardization. So finally, our cost will be reduced. Initially, we thought that the cost increased a little bit because of that's investment. That's investment. After that, the cost should be reduced, and then we implement lean. We eliminate mudah, muri, murah. So it should be reduced. So it reduce. But until one time, you will notice the cost increase. When this happen, you stop and stop. Because this is your maximum quality. You already reached the maximum. You cannot go further. Otherwise, the price is going to be expensive. And then you might lose your
Meaning 3 sigma is enough, for example.
yes.
That's the way the optimization.
You remember what I have sent you last night?
Yeah.
Dr. Walter Sheward, based on the economic reason. That's why he said he put a 3 sigma. 3 sigma is economical. It's okay. 6 sigma, excellent, good. For the company, if they can achieve 6 sigma, it allows them, because if I were to go to the SPC,
Apa pasal 3 sigma dengan 6 sigma?
Yes, yes.
okay, start with this normal distribution curve. This is 3 sigma. As agreed by Dr. Walter Sheward, in economic perspective, that was done by him 100 years ago. 1920, 28 now, almost 1920 to 1930 now, 2023, 100 years ago. Dr. Walter Sheward observed that this is the economical standard deviation that industry can afford to have this. I think it is still valid until today. So, in 1980s, I think, General Electric and GE and Motorola, they introduced 6 sigma, which is the standard deviation is extremely lower. It's about divide by 3 of the 3 sigma. So, when we improve to this 6 sigma, actually the upper limit and lower control limit remain the same.
Correct.
Same lower, because this is industry average. You cannot change this. Otherwise, all the quality guru in this entire planet get together in one conference. We agree we want to change to 6 sigma. Then crazy, all the industry will object. You agree, no? Because it's a cost. But what I want to say is 6 sigma is just idea actually. It's idea. If you want to improve your target for 6 sigma, that's why we do Lean 6 sigma demand. Those who still new about demand, you can Google, ask ChatGPT what is demand. But majority of you know what is demand. Demand approach: define, measure, analyze, improve, and control. Okay, I go a little bit further. Demand, and then we have 5S. The last S is the sustainability.
Sustainability.
Sustain. So sustain and control. Is it? You have done your 5S. You have done your first S, second, third, and then fourth and fifth. So this is sustain. So these 3 we done at the shop floor, and this 4 and 5 will be done by management. So management has to set the regulation, the discipline, so that everyone will follow. And of course, set standard, and then they have to change the previous work process. Because after 5S, we have introduced a new one. For example, I have done my 5S in my office, for example, in my drawer. So I have to set standard. Instead of after a year I just leave like that, I have to make the discipline, keep it. And I have to make that as practice. So training is required, then observation by the management to make that as discipline also important in 5S. So that's why 4th and 5th is the job by the management, and this is by the shop floor, by Gemba. Similar to this demand. After you improve, you control. So to control this, who should do the control? the management. So it is similar to the fifth S. So in order to make sure what you have improved remain, you should change the new work process and then you should give them training. And of course, change management is very important to allow them to change with the new habit. So you monitor. Usually if they do it 40 days, probably that will become their new habit. Sometimes it's very difficult. One of your colleagues, you're from improvement team, right? You. There was one, I think Najwa.
Yeah.
You, improvement
Yes.
team. Do you have difficulty when you make improvement, example Kaizen or whatever, you improve the work study work method, and then those from the production, the member, we object.
Yeah, always.
Always. So, you know the difficulty, yeah, at this part. On this one, C. Difficult.
Sustaining is the difficult.
Something difficult. When you resign, you join in the company, they will celebrate. Yeah.
They will take CI with
Yeah. Okay, see you.
Okay, see you.
Yeah.
Bye.
See you. See you, okay? Okay, bro, see you. See you.
Okay.
See you.
So you celebrate Christmas, huh? Okay. So class, Christmas Eve.
Bye.
Alright.
Surprise.
Yeah, thanks.
Okay. I also face same experience. I shouldn't mention the company name because all of you know this company because I've signed the NDA. But there's a gap in the company where improvement team is under cost control department, or the industrial engineering and so on under cost control department. Also supply chain under cost control department. And production department is a production. They just do the production. Production planning is under cost control, together with the improvement team. So I was appointed by the improvement team in that company to propose for the improvement, but the KPI given to me, I have to suggest to lay off 40 staff and lay off because to lay off the contract staff, not the permanent staff. Contract staff, they have what we call it payroll. You know payroll.
Yeah.
Payroll. They should go to the jail, but they didn't. That's what we call payroll under police observation. Working in the factory. You imagine? That was my first experience knowing that payroll is working as contract staff in the factory. And then they'll have all the Myanmar, Bangladesh. Those Myanmar, Bangladesh, they were sent to the factory by the agent. So today, if you have more production, you want 30 additional workers, they will send. But that workers, you have trained the moment you want to do work. So how does it get quality? Because they do not know what to do. So until you train, so you're working from 8 to 5, so you have to spend 1 hour, 2 hours to train them before they start work. It's a problem. Problem, right? And then they also employ part-timer like suri rumah, what you call it in English? A housewife to work part-time at the production. And they also have their own people, own staff, full-time staff. I'm aware about that, so I want to maintain their full-time staff because very difficult to retrench the full-time staff. I want to get rid of this temporary. Okay, finally I've got my suggestion. I did the time study, I did the Yamazumi. You know Yamazumi? You will learn in the lead subject, Yamazumi, how to do the line balancing and so on. Using Hijunka, Japanese we call it Hijunka. Because we want to avoid the murah. Mudah movie murah. We want to avoid, eliminate murah, we do the Hijunka balancing, line balancing. In the office also you have to do this Hijunka. Because you observe there are staff very busy, not like the Japanese one who sitting in the tourist coffee house. really busy. And there are staff, relax, 5 o'clock can go home. So if you observe that, you have to do this to balance out the workload. But of course, they are not happy as well. They are not happy. Okay. So I face a problem when I do this improvement. When it comes to the line trial, the production will object. There's a lot of reason, or we pushing for the target and blah blah blah. And when we have done I have to do about 20 line or 30 line. There are a lot of variants there. Sometimes I accidentally tell you the product, so I shouldn't tell you the product. Else you can guess which is the company. So 30 line, 36 line, if I'm not mistaken. So only few line give their commitment. So then we have suggested how many workers, how to combine process. Those who are already relaxed, so we combine, so they have same pace of speed, same work time, work what you call it, cycle time to do the task. Okay, this line, for example, we eliminate 5. In the record, it's really eliminate 5. So the company is not paying the salary. This is internal process of the company. It's not paying salary for that 5. But when you go to the line, that 5 still exists. This is what we call ghost in the production. Not just in that company. There is another automotive manufacturing also facing similar problem. They call it ghost. How that another 5 got the salary? Because production is different department than the cost control. Cost control lies with the HR. The salary given direct from there come from the cost control instruction. But department, they have their own ways to pay for that another 5.
So in terms of a legal and policy company,
because they are what we call it part-timer. Their salary paid.
oh, so
By
day
day.
is a day
It's a day.
paid by day.
They are not signed for any legal requirement. So that's always a problem to implement this. You employ consultant from US, help you on the demand, and finally you pay but no improvement.
Is it because it's a very poor involvement from the executor?
Executor is a production, of course poor because they want to protect their territory.
So they are
Intel
not,
different, I think. Intel different because
so
you have
sometimes they are not
American
very,
mentality.
they are not very convincing of the change.
Yeah, they don't want to change. That's a hurdle dealing with production.
That's why you cannot sustain.
You cannot sustain. Hurdle. Am I right?
100%.
That's why we need automation. Automation. Production, kind of, they like the chief of the production, they like there's a politician like Ketua Kampung. They want to protect their territories. Their territories. Okay, as supervisor, I know already you want 12 hour overtime, you want 10 hour overtime. Make sure I guarantee you overtime. So they have to cheat. How much you improve to reduce overtime? Because the burden for that company overtime 30 million a year. So they give me 427,000 ringgit for 1 year project. It's just to help them to eliminate that 30 million. It's very little investment.
And if you want to do for saving project, eliminate OT, the operation people automatically will say, before they start the saving project, they'll say, do not touch OT part.
Yeah.
It's literally there in front of the finance to
Ah.
touch. So you cannot do improvement project over there.
Cannot do improvement.
Yeah, it's like
So it seems like we have to control alternate delete like computer, reset the entire company. There are company they just reset. If you notice, there are company in Malaysia they reset, close, and open up in somewhere else, so they can start all over again. That's only the solution. I think. You know, imagine I go to their warehouse keeping the part. Then I ask, okay, this is part A. I shouldn't mention the component. If I mention the component, you can guess what is the company. I want to find this component for this model. Where is it? Oh, you have to find this like you want to find book in the Pustaka Mukmin. You know, have you been to Pustaka Mukmin?
Yeah.
Huh? There are a lot of book. Only the
Salesman.
salesman knows where they keep the book.
Yeah, I went there.
He went there. Pustaka Mukmin in front of restaurant itself.
South.
Pustaka Mukmin, Minerva I think better. Mukmin, you couldn't find the book by your way. So the situation of the warehouse of that company is like that. Horrible. You don't know. Okay, this component should be here in this rack, but it's here. Why is it here? They don't know. There's a problem in our real manufacturing industry. So I go back to this one. So so what happened here? After you have, well, if we have Six Sigma, there's a clearance here. You can see the clearance here. So if I try to show you first. Okay. If anything happened to our tooling, for example, because of the age of the machine, maybe the bearing or the alignment or something, so it might squeeze to here, shifted here, but because of you have improved to Six Sigma, we expect that there will be no rejection. So what is the philosophy of Six Sigma? Is to have a robust process. Robust process. That's the idea of Six Sigma. Almost impossible for you to improve until you got the standard deviation that is Six Sigma. But as long as you have zero rejection, but ideally in statistics or perhaps Motorola says 4 defect for 1 million opportunity. Statistics say less than that. It's about close to 0. But Japanese said impossible Six Sigma, we want 7 Sigma.
So
Motorola is American, they always realistic. America always realistic. 4, because we human, not perfect. So 4 defect for 1 million. So if we have 3 defect for 1 million, it's okay. But Japanese say no, Daijobu ne. Daijobu. Cannot, impossible. They want 100% accept. So this idea provides us robust process. So by using DMAIC, the target is we use all this quantity tool that you are going to learn next week, so that we can squeeze our standard deviation, so that we still have allowance for the wear and tear. That's the idea of Six Sigma. Any question?
okay, for example, Japan try to move to 7 Sigma. How about in terms of the cost that they need to ensure they meet the 7 Sigma? Is it increase or?
Actually, their cost is high. Why high? That's why when you buy product made in Japan, it's expensive.
So why we need to go to 6 Sigma if the economical value is saying 3 is enough or 6 is enough?
Customer requirement. Economical, yes, one thing, but you have customer requirement. So that if you buy a recon car from Japan, that's high value. But that car is considered scrap in Japan. They cannot renew the MOT. So actually there is a process. I've been training in Japan for 1 month about ELV. I know this. I went to the inspection center. They just 5 minutes to inspect the car, and then got the result. And all the mechanic will check the car. They are analysts and they didn't see the driver. So there's no chance of bribery like here probably. So if the car fail the inspection, there are 2 choices. Either they repair the car and then come for another inspection, or they send the car to the scrapyard. The scrapyard, they will check the car again whether this is suitable for second hand. That's what you call recon, export to Malaysia or elsewhere, or they dismantle the car and then get the valuable parts to recover the material. For example, there is a gold in the car. There is palladium in the car, very high valuable material, so they melt and then they use to make another product. But those who they want to put as second hand, they will export to Malaysia and then Malaysia, Thailand or whatever, and they will repair in the targeted country. So that's what they are doing. So you imagine you buy a car, second car from Japan here, that's a quality, very high quality, yeah. So it is Six Sigma, but they don't want to use that car anymore because it's failed inspection. But you buy the car, you can tolerate with minor repair. You got a high quality car. That's why if you listen to the noise of the engine also different, because the tolerance is different. When we talk about this, it should be to the tolerance. So I agree with you, the cost will increase because the tooling cost will be increased. Tooling cost will be increased. You imagine your machine to cut the crankshaft shouldn't be a same machine in Proton because the target for accuracy is very high, the standard deviation is very low, and probably the tool change is more frequent than our machine here. For the CNC machine to cut to do the cylinder block milling machine and so on, the tooling presetting has to be more frequent, so they have to stop very frequently to change the tooling. And of course, in order to reduce cost for that, we call it in lean SMAC, single minute of exchange of die. So they have to improve on the SMAC. That one you will learn will be under lean operation cost. Okay, any question about that? Okay, so I go back to this one. The idea of this one, we stick with the 3 Sigma, but I've explained to you what is the 6 Sigma idea all about. So why don't we turn this way to the counterclockwise? Turn to counterclockwise, it becomes, this is what I have explained just now. Then we turn, comes like this. So this is the target value that we put in the drawing, for example. You design a crankshaft, this is the diameter of the crankshaft. And how do you got the tolerance? Probably we got from the manual, but actually the tolerance comes from this 3 Sigma. So you have to plus 3 Sigma, then you got the upper limit, minus 3 Sigma, you got the lower limit. That's the idea. So in the drawing we put the tolerance. Yeah, plus minus. But during undergraduate, when you learn your engineering drawing, you just put the tolerance without knowing how to get the tolerance. Any of you experience it? Maybe you have better knowledge than me about how to put the tolerance. Usually you find from the manual, but the manual also based on this. So if you want to have stricter tolerance, 6 Sigma, so that 3 Sigma divided by 3, so that is the tolerance. So it will be smaller. No, this is 3 Sigma. So you divide by 2, this one. So you got the Sigma for 6 Sigma. So if this distance is 0.2, right? 0.2 divided by 3. So that's the value for this upper limit and minus that one value for lower limit. So you have very close tolerance. So you have, if you set that close tolerance, while the internal standard still here, so you have no chance of rejection. But again, cost expensive, tooling cost will increase. I'm sorry, those who are not from the manufacturer, you might confuse because this is more on the basic engineering. All engineers have to learn engineering drawing. So now I'm just to justify how do we got the upper limit and lower limit. And this is the value that we want, but impossible we can cut anything very precise. Although we have the precision engineering. Precision engineering is very expensive. That's why product from Switzerland expensive. Swiss watch is expensive. But now people don't want to buy Swiss watch anymore because we have what we call smartwatch.
How we get 1.960?
This is 3 sigma.
How we calculate 3 sigma from 11?
From the data,
Okay.
we calculate the standard deviation. Sigma is standard
Okay.
deviation.
Okay.
Standard deviation multiplied by 3, that's the distance.
So, but the standard deviation is a simulation data, actual data.
Actual data. Actual data. But actual data, that one is a company policy. For this process, what is our value for standard deviation? Because in the company, they should have their historical data. We cannot simply put the sigma based on the data that we have.
Okay.
Maybe that is not really accurate. Or if your tooling or your machine is new that time, you can have very small standard deviation and you multiply by 3. So that's 3 sigma, but that will give you disaster later on. So you have to be realistic, you have to have the data in your probably society automotive, they have their ACE, so they know already what is the sigma for that particular process. So from there, they just multiply by 3, so they have the limit.
Because last time when I was in it's a concrete industry, so I become one of the QC. I monitors the quality of the concrete. Okay, so we have a 1 day, 3 days, 7 days, 28 days. What call it? Quality strike. Queuing. Okay. So during that time, I'm not sure. I don't know this 6 month everything, but I just plot this graph. So that's why during that time I was thinking, because actually, for example, the grade 30, for example 30N is 30 normal, right? That should be the strength at the 28 days is 30. Okay, so the 30 is because of the middle, right? So in terms of standard deviation, we are not sure. There's no any record saying that what the standard deviation and the particular years or the particular days or what kind of reference. So in terms of that, how are you going to translate this the available data right now that we have into the 3 sigma or 6 sigma evaluation?
There is one way. Actually, we can simulate that. We assume normal resolution distribution, like this one. This is really no, not this one. Normal distribution, say sigma. There is a statistic way actually for you to reverse engineer to get this value. I cannot explain here because it's more statistic. But in practice, we are not doing that. In practice, either you base on your own company, if you do not have a good society, you base on your company data. For example, for 1 year, you have data for 1 year. For that particular 1 year, you calculate the standard deviation. That is your capability to produce that for that sigma level. So you multiply that by 3. So, but if you have association like automotive, they have their standard. I believe the concrete or cement producer, they have their association, but I do not know how they collect or keep the data that related to quality. But automotive is very established.
Because of course we don't want to overspec, right?
Yes.
Because we are wasting.
Why for your case, for example, why you have to refer your own data for 1 year? Why? Because if you refer to another company that is more efficient, for example, the one that you mentioned, European one yesterday,
Yeah, dapat.
Lavash, maybe their sigma is smaller than Seremban Cement.
Yeah, Consima.
And then that caused disaster to that Seremban Cement, so they have lot of reject because they are referring to wrong
Historical data.
standard. Because we have to compare apple to apple. That's why somehow or other the benchmark is also important here. Okay, is that answer your question?
Okay, alright. So just get I think just get the baseline and then for improvement we change the SD.
Yeah. Okay. Then what to do? This is just example X bar R chart. So what we want to do is we have the data like this. Sample measurement we call it subgroup. This one we call subgroup.
Ni dia punya
Subgroup,
test.
subgroup or sampling, something like that. So let's remain standardized as subgroup because this will be the population and this is a subgroup. Each time we collect the data. Because this is X bar, is average, the bar is average, the mean.
The mean.
So we have to get a couple of reading, 4 or 5, 6, whatever. But actually this is a, it will affect the formulation also actually. Later I will show you. So let's say we read 4 times for this one. This is a sum, and then this is the average. 112 divided by 4, we got 28. So the range, the highest 33 minus the lowest 24, we got 9. Similar to others. Is it okay?
Yeah.
Yes. With the range.
Then from here we plot. We just plot accordingly. X bar this one, range this one. How about the middle line? The middle line is we take the average of all the population, or perhaps we plus this, then we got the total divided by how many data that we have. We got the average. Basically, the average of all this. And how to calculate the for range, also average for range. Total all this divided by how many subgroup we have, we got the average. But how to calculate the upper limit and lower limit? Average plus 3 sigma. If you love statistics, you can calculate the sigma. But actually easy for you to calculate sigma using Excel. Easy. But you have to aware about there is a difference between standard deviation for sample and standard deviation for population. The difference is on the formula divide.
The mean.
You can open up your Excel, click half, type standard deviation, STDEV. That is the formula, the short form for standard deviation. And then half will show you standard deviation for sample and standard deviation for population. So the difference for population they put n divided by n, and for sample divide by n minus 1. That's the difference.
Oh, number of sample.
N is number of sample and the subgroup. So the small n is here 4. 4 minus 1, 3. The capital N population. How many population we have? 1 until how many? So if you use the Excel for population, if you wrongly give the command, this is the command under Excel, stdev dot p, then you highlight all the data, and or you give stdev dot x sample, they will give you different results. Because you are using Excel, and then later you calculate by your own, you know which formula you are using. But this time, we use computer Excel. So you have to know what is the command for that. Okay, forget about the graduate. Last time you calculate, your lecturer give you 10 data. 10 data is very difficult because you have to plus all that. Usually in the exam they give you 5, so you have to calculate. You got your answer. Compare to your next time, okay, correct.
Compare dekat.
Compare. That's normal undergraduate. But now postgraduate, you have to use Excel. Because in the company, when you involve in the DMAC team, Lean Six Sigma, you also use Excel, and then you have to plot using Excel. OBI is very advanced, so okay, no problem.
So
My experience when I visited a company, they use Excel. Excel is a basic level.
So in this case, we are using sample or as a population?
Population, to calculate the standard deviation for this one, the sigma for the upper limit and lower limit is based on the population. Sample is all for this one only. This is sample. Okay. Population. So we use this stdev.p. There is another SPC. They call it standard deviation and R chart. So for that one, you have to use stdev.s to calculate this. So you have to highlight this. Give command equal stdev.s, highlight this, and the Excel will give you the standard deviation for each. Then you plot the standard deviation chart. When you want to use standard deviation chart, when you want to use the X bar, it depends on how many sample we have for each subgroup. Later I will show you. For this one, since we have only 4, it's reasonable to use average. But as engineer, we don't bother about the number, whether it is standard deviation and average. The number, the difference is very small. So why must we give headache? Because when we want to calculate if you do manual, very difficult to calculate standard deviation. But if you accept, okay, you just give command. But engineer, we don't like to do that. Statistics like to use median. They plot SPC for median, they plot SPC for standard deviation. But for us, engineer, X bar, R chart is good enough.
How about this calculation? The last time I do the concrete, I not compare to the mean, but I compare to the targeted value. For example, as I said, mentioned the 30n. So all is minus 30 instead of minus mean to calculate the variance and standard deviation. To see how it deviates from the targeted value.
Oh, you just compare, okay,
Yeah.
this is your target, and this is what you got.
Yeah.
So do you have the lower limit, upper limit?
Yes. It depends on 3D. It's even 3 sigma. You can do that.
If you have the value for sigma, I think it's okay just for the practice. But if you want to show to the third party, because that is not standard approach, so better you have SPC.
Because we want to say that how accurate the result that we get.
You
right?
show how accurate, but based on one sample. But we want to see the trend of your entire week or entire month of production.
Yeah, but the quality target is 30.
30
Yeah. So everything is a minus 30 instead of minus mean.
minus mean. So you are more on the lower side. For example, that is, this is target 30.
Okay.
This is upper. You have the sigma, then you got 30.01 for example. This is 29.09. Okay. So yours always here. Is it what you're saying?
No, 30 is a targeted. We
This is
try to
target.
shift the mean as a 30 as well. So that's mean majority of the distribution at the 30.
At 30.
Yeah.
Well, you're perfect.
No, that's the target. So that's why that everything we start with the 30. So we see where we are now.
Yeah, this
then we
is
try
your
to
mean.
shift
This is
it.
requirement.
Yes, yes.
Then you have the sample, you test your sample,
Yeah, they see
30.
Yes.
Then you test the sample 30.
That is good lah, right?
Yeah.
Good, perfect. 90.
But surely it's not.
It's
So
not.
that's why the baseline, let's see, we are minus everything with 30 because we minus with the targeted value, and then to see where we are, the curve, and then we try to
And if you
twisted
get
it.
the value, this is what you want.
Yes.
Then you test your concrete, you got
Maybe 32, 31, 35,
okay.
and then you see the distribution is like the bell curve is
like this.
Yep.
Like this. Then
Yeah.
you got here. It's not good lah. Then you got this one. Not good lah. Reject.
Is it okay or
That's a normal, is common lah. But why do you plot this way? So that you can see the trend. Whether your trend towards upward or downward.
Sometimes we also see that to identify outliers,
Yes.
measurement, right? So when we do the normal distribution, we discard the outliers.
Yeah, we delete the outlier. After this, I will show you how, because this is the outlier. After this, we will deal with this outlier, how we're going to do that. Okay, this is the formula because engineers always lazy to calculate. Now we have SPC software, so they use IoT to do the detection, and then the system, you just click what you want, they will tell us. But in this class, I have to share with you the fundamental. In practice, when using this anymore, everything is computerized. But if you work in the SME, you have to do by your own. Like auditor SME, because they don't have, they cannot afford to buy the software. Excel, because they buy laptop, they have free Microsoft Office.
They don't waste their time.
So they collect manual at the site because they don't want to bring the laptop. And then they go to the office again, they key in. And then they plot.
yeah.
You're working in a big company.
I did it before.
They key in manually,
Yeah.
and then ask how to plot this. Because they are doing it last minute. Tomorrow ISO audit. Then show to the auditor. During audit, during COVID, okay, when the auditor asks, then it's kind of like busy over there. Suddenly they have the evidence. So they create during the audit. Is it common? Yeah, it's common, right? Common. Auditor also know. So what to do? Because when we audit, we have to see the compliance, what they comply. As long as they comply with. When they do not comply, we have to provide the non-compliant report. Non-compliant report also headache for us. So as long as they have, okay, they have. They have evidence it. Whether or not they're doing it last minute, it's okay. So in SME, they do it manually. Manual, so waste of time. Because they cannot afford to have the IoT. But I visited one factory, plastic recycle in Nilai. They built their IoT things by their own. Because the CEO, young people, young Chinese man, very young, 20 something, he liked gadget, IT. So he employ UTM graduate, young UTM graduate who gadget savvy to build all the IT. Even they can monitor the energy consumption of the machine. So he can predict how much he's going to pay for the electric bill. And then lorry deliver them the recycled plastic. And then there is a camera there who will identify whether this is PE or PP. Using vision camera. Weightage to weight the stock oil, everything digital. But his father always complaining about him. Why? Because the father asked, I spend a lot of money, where is my money? Because this is gadget, oh you like camera, sensor. How this relate to the money?
ROI.
ROI, asking for ROI. No problem. Okay, so we go back to this one. So how do we calculate the R bar is the average of the R, and X bar is the average, but average of this X bar. And how do we got the X double bar? Average, total average of this, we divide by how many population that we have. K is the population, so we got the answer. And about the A2R, this is the 3 sigma. Since engineer, you don't like to calculate the sigma, because you imagine if you want to calculate that, how many data that you have in production for 1 month. You don't have time. You are not undergraduate student who learn statistics. You are doing the real thing. You want to use Excel. In Excel, you cannot highlight all data like that, and then you ask them to calculate sigma. They will definitely give you a wrong answer. So you have to sort the data. You don't have time. So we use this table instead of using the statistic value. So for example, this table A2 depends on what? Depends on how many samples that we have for each subgroup. So for your case, if you want to know what is the distance for the upper limit, for each testing, you have how many samples? Let's say 3. So 3, so your A2 will be 1.023. Then you multiply by your range, R bar, average of range. So we assume that is your, what we call 3 sigma. Maybe it's not that accurate, but it's acceptable by the industry. Okay, you understand or not? But pertaining to the R bar, it still depends on your data. It's really unfair if you want to take R bar for that particular week or particular month. So I am advising you, if you want to refer to, actually if you want to compare, of course from this plot you have to, your R bar should be your that particular month R bar. But if you want to check your, what we call it, or whether you maintain the level or not in terms of your 3 sigma, you have to compare this R bar with the entire year, for the whole year. What is the R bar? Because you want to see whether it is, how much is deviation. If the deviation is too much, then you have to check your tooling as well. Maybe you have problem with your tooling, so that it will affect your accuracy. Accurate is still accurate because it still lies on the mean, but if you have accuracy problem, that will affect the distribution of your data. And
basically R is related to the tooling itself.
Yeah, distribution. Tooling, maybe the raw material as well. For example, when you cut crankshaft, for example, crankshaft is cast iron. So maybe if your tooling is okay, because we can use AI also to monitor the vibration and so on. Maybe the noise vibration is okay. Maybe the raw material that you got, the crank, what we call raw cast. Raw cast, you understand what raw cast? Raw cast is the cast product that is raw after going out from the casting process. We pour and then we knock the stand and then we got the raw cast. After we clean and we remove all the edges, and then we bring the raw cast for the machining. So maybe the raw cast quality. Even if we cut mild steel, there are different what we call it, distribution of the carbon in the mild steel, so that will affect our purity as well. Yeah, the purity of the mild steel. There's more on the material side. Similarly to proton, when they change their material, this is cost reduction initiative. They want to reduce the cost for body, so they try thinner sheet metal. They reduce the thickness of the sheet metal. So when they want to reduce the thickness of the sheet metal, they have to change the material as well. Why? Because it affects the strength. So when they change the material, of course they still mild steel, because Proton can afford those steel. I don't know today. Those steel for making Azola, they can afford to use aluminium alloy. They use mild steel. So they reduce the thickness, of course, in order to maintain the strength, they have to change the composition. So when they change the composition, they got the thinner sheet metal. Why is the problem arise? They overlook the painting side. Because when we paint the car, we have to do the galvani, or what we call it? Electroplating, to protect the body from the corrosion. So they have problem on the electroplating, then after electroplating they send to the painting. And then they have problem at the top, especially paint is not really stick there, and then at the fender side. So that's why the height is the plastic molding at the fender, at the door underneath, and upper side no one will look after that, so they just ignore. And that one on the painting. So they also have problem on the stamping. When we want to stamp the sheet metal on the die, there is a calculation, stamping force and so on. And then the clearance of the die depends on the material as well. So when you change the thickness, the dimension of the die should be different, because the clearance should be different, and then the stamping force also different. So they have problem, aging problem. So they need to rework that process. So they need workers to do the after process rework. So there's a cost. So they want to reduce cost on the material, but they incur cost for workmanship and process. So finally, they didn't reduce cost. So what I want to share here is, when you want to do cost reduction, it must be holistic. Shouldn't consider, okay, only R&D reduce cost. How about the process? That company, they didn't get feedback from the process, because it's focused, okay, R&D. Okay, so we go back to this one. So A2, because previously we have 4 samples for each subgroup. So 4, we take 0.729. We got the R value, R bar, X double bar. So this is the answer. So the X double bar is 6.12, R bar is 2. So we have the value for upper limit and lower limit. This is how we do this. And then we have this upper limit and lower limit. So I would like to share with you, because this case we have only 4 samples for each subgroup. But how about for this case we have 10 samples for each subgroup? As engineer, no problem if we use X bar. But statisticians, they are not happy with this, because they said if we have log n, we should use standard deviation chart. But we forget about that. That's the, what you call it, school of thought. Statistician likes accurate things, but we don't mind, as long as we got the result. So for this case, if we have 10 samples for each subgroup, this is subgroup, 7, 6, morning, afternoon and evening, maybe night is one. They take 10 samples, then they got the X bar and range. I think you know already how to get this X double bar and R bar. So when we have this 10 sample for each subgroup, this table we only have 6 until 6. We cannot use this. We must use the big table like this. 10, so E2 is 0.31. So E2 0.31. So after 6 sample for each subgroup, we start to have lower limit for the R chart. If you remember the graph, this one, we do not have lower limit for R chart because we only have 4 samples for each subgroup. If we have more than 6, we are going to have lower limit for the R chart. And remember, the value for A depends on how many samples that we have for each subgroup. So, calculate as usual. We got the upper limit, lower limit, and then the double bar, and then our upper limit, lower limit for the R. So what happened? This is what you asked me just now when we have an outlier. This one, outlier, this is upper limit. I think you already know how to get this lower limit, upper limit, and X double bar. So now we have this outlier. We cannot just simply move this upward because it depends on the A2 and our R. R bar is actually the deviation. R is related with the standard deviation, but because we want to simplify it, we forget about standard deviation, we use R. But the indication is the same. So we have to delete this. We eliminate. In practice, what do we do? Actually, this is following the book. If this sample subgroup number 7 represent 100 pieces of production. This is sample. What should we do? There are 2 ways. Whether we try to retest this, take out another sample, test, check the difference, whether it is still outlier, or if not, okay, Malaysia style, okay, lot. So, boss, okay, no problem, because you're the one heading. But Japanese now, they start to worry about, oh, screw that car. You know, they will 1,000, they will throw.
Nandeska.
They will throw. You remember that you watch that video when they have propeller shaft problem. They throw the entire lot of propeller shaft. And then they will do the Genchi game also to find out the root cause of the problem. And finally they realize the design. There is a curve stress concentration. When you cut, you should allow the curve so that the stress will be distributed. Because of stress concentration, they have to destroy the entire lot of the crankshaft. And it is history in Toyota. It happened in Toyota when they receive complaint about the propeller shaft. So for this one, we have to remove the entire lot actually. How much is the cost? It's very huge. If you are, this is a crankshaft. This is one sheet, for example. You take 10 samples for this particular sheet. You are producing about 100 crankshaft. Maybe you have to remove all that 100. So how much it cost? One crankshaft costs you around 2,000 ringgit. So that's a loss due to poor quality. So we remove that. When we remove, we re-plot the SPC. There is a book that giving you formula. I don't want to make you confused, because in practice you just remove the data and then the graph will show a new graph for you. But in reality, actually, when we remove, when you remove this subgroup number 7, what happens is your number of population is reduced. Instead of initially you have 15, minus 1, you have only 14. So your X bar will be changed. X double bar will be changed. And up bar also change. And your upper limit, lower limit also change. Then you replot again, then you have another outlier. So remove this one again, then we have this final. So although we agree with this, of course the product that represents the subgroup number will be delivered to the customer. But this is something that alarms us. What should you do? You have to investigate. Because this is pushing towards upper limit and this is pushing towards lower limit. You have to find out why.
Stable the process.
Yeah, maybe something wrong. That's what we're going to discuss next week. Ask for 5Y and so on. For example, this one, okay. This is explanation here. Normal behavior, okay. One data point goes outward, investigate cause of poor performance. Reduce also investigate for cause of the. This is the. I not really agree with the connotation improvement when it goes to the lower limit. It's also poor performance. Good means it beyond the mean. So we have to check all this. We have to check. That's why Genchi Genmusu is very important. When I teach Lean, there is a video that I show my student how manager doing the Genchi Genmusu. The manager go to the shop floor, go to the board, there is a board written there, what is the problem. Then okay, this station, go to the station, see the team leader, and then not just listen to the team leader, ask the team member. Because team member is the one who do the work. Ask his opinion and then again empowerment. The team member is the lowest operator, lowest level operator. Give opinion to the manager. Okay, this is okay. This suggestion is not repair. If you delay the repair, it will happen. This affect the customer. Blah blah blah. Okay, then the manager have an idea. Then the manager again go to the board, write down what they have discussed, and then he sign. Then chop the income. Japanese always bring the stamp. They believe on the hand signature. That's American. British use the hand signature. Japanese use income. Similar to Chinese use income because it is registered. They are registered in the government office or income. I have one income which is registered, but I don't know whether it's still valid or not. I have a registered income under my name. Then put income there. So later they will meet the follow-up, and then the manager will inform the maintenance department that there is a problem that they need budget to repair and so on. So that's how the manager do the HG also. So you have to do this actually. When you have this kind of phenomena in your SPC, so you have to investigate. So to answer your question about the company, whether or not we just based on the what you got, whether it is close to the target or not, without plotting the SPC for the entire week or month, my suggestion is better you plot it because you want to see the trend, you want to see the behavior. If you just based on one dot or average of 1 day average concrete, okay, it is here, so it's still beyond the limit. Without having the trend data like this, you cannot see your actual performance.
Actually, we have, but the CL is a targeted value, it's the mean value.
The CL, the control limit.
Yes.
The target value should be here in the middle. Should be here. This is your target value.
The
This
CL.
is your X double bar.
X double. Yeah, X double bar is the mean, right?
Yeah, the mean. This is your target value.
Okay, so actually in that in the normal quality, for example for concrete, for 30 normal, it's 30.
30 is here.
Yeah, 30 is here. Yeah.
Okay.
So it's not mean, it's a targeted value.
The targeted value.
Yeah.
But yeah, this is another approach in robust engineering. We call it mean adjustment. So let's say this is 30.
Yeah.
Suddenly, when you have your data, you calculate your external bar, it is not 30.
Yeah, that's why.
It is here.
Yeah, exactly.
So what should you do?
First, we check the accuracy of the machine. Because is it real? Because we see the consistency first. Is it consistent at the 29? That means our machine is consistent, but is it give the right value? Okay, so then first we check, we calibrate. So yes, if the calibrate okay, that means okay, we are still around 29 consistency. That means we are still within the range, no limit. So actually, no much we get. I think no, still within the range. We don't take too much actions.
Yeah. But if it is far from this,
far from it and consistent.
Inconsistent.
Yeah.
So there must be something wrong with your equipment because your equipment capable only to produce that much. For example, machining. Target value is 28 millimeter. We have tolerance, but all the time when we cut, we cannot get 28. We got 27, for example, or we got 28.1. We got consistent around that. So, but our customer wants 28. So we have to check whether we have tooling problem or our tooling okay. We check our material problem because some material brittle or material, so that they cannot give us the accurate cutting dimension. If it is what is mulu English? Ductile. If it is ductile, then it have the accurate dimension. Ductility and the cutting angle also important, and then the hardness, the type of material to cut the workpiece. This is my analogy about machining. But concrete, because I haven't been in the concrete, but I also believe because the hardness is also related to the raw material. Because in concrete industry, your variation of your material is very big, similar to the food industry as well. But in automotive, we can control the variation because we can control during in the furnace.
How about, for example, quality parameters like a pH, for example, like conductivity of water. For example, we have the water analysis. Alright, so the water analysis is the turbidity, for example. So at the center is actually the targeted value.
The targeted value, standard value.
Yeah, for example, turbidity, 30 NTU, right?
Yeah.
So we are monitored on this. So for example, as sudden that NTU is upper limit or in the border upper, but it's consistent. So actually we said okay, our equipment is reliable because they are giving the consistent, but only the value. But we can check the accuracy, we calibrate. Still is okay. That means we are now targeted a bit shifter, a bit higher. So to optimize it, we try to moving downward. Maybe we can reduce the chemical injection. For example, that's what we do.
Yes, I agree with that. Okay, let I give you one example. In statistical robust optimization, that approach we also call mean adjustment, adjust mean. Okay, let's say our control factor is the diameter, length or whatever. Then we got the optimal value. This is what we have the what we call it mean based on the optimization of this control factor. So we know that the diameter should be this much, length should be this much, maybe material should be this material, and from there theoretically we know this is the value that is optimal. this is based on our design. But the market says they don't want this, they want this one. This is by market or by the standard.
So now it become our new target, right?
Yeah,
we
new
are
target.
moving, we are shifted
But
to the right.
our design doesn't give this value. I think similar to your water quality. But our data shows there is a distribution there.
Yes, we have to shift.
So what should we do is we shift the mean. We do the what we call mean adjustment.
Okay, right.
When we do the mean adjustment, that's why we need to do statistic as well. In Tagochi, we use signature loss ratio. So from there we know what are the variable is important. In statistics we use ANOVA. So using ANOVA, we know also what are the variable that is really important, highly significant. That's statistic. But in Taguchi method, we call it high signature loss ratio. So that is highly significant. So we adjust this parameter so that we can adjust this. But let's say we have 4 parameters that is important, for example. Out of these 4, we can adjust all the 4. We adjust one by one. We give priority to the lowest cost. The philosophy is cost. We adjust at the lowest cost. If we feel that land is cheaper than others, so we try to adjust land because we have the range for the land, for example, Y to X, for example, the value for
The value.
Okay. So we adjust the value, whether or not it will shift the line, the mean. If we can get this mean, and then we stop. So that's it, done. This is how we do in what we call a design for quality.
So in selection of the for example, you have a for the contribution factors.
Yes.
So we select prioritization based on
Cost.
the cost or the contributions, the R2 value.
Contribution, they are contribute.
But okay, whichever they are giving more.
The highest contribution, of course, we have from our ANOVA, we know
R
this,
square.
probably this is the highest contribution. But the highest contribution not necessarily we can afford to do this
Okay, alright.
because cost. So better we refer to the cost.
Better we go to
We
cost.
try at the lowest cost whether we can adjust the mean or not.
Okay.
Then if we can't, we try another one.
So we will call it we perform like a metrics performance
Yes.
evaluate.
Yeah. Similar to the water quality, you want to adjust so that the water quality will shifted to the standard. For example, Shabas, they have standard for the water quality. So they know what are the variable that
Yes.
important, that really affect the water quality. So they adjust, but cost must be in their mind.
Exactly.
This is different. Academic university lecturer, they always think about the value. Oh, the highest, of
Yeah.
course, the highest can shift the mean. Can you afford to do that in industry? And sometimes you cannot, in practically, really, you cannot move that. How could you do that? Although it is really influence. So we have to be realistic.
But that's why sometimes in this issue we are more concerned about the celebration and also the consistency. For example,
Yes.
if the mean is 11, but we are now consistent at 10.5, for example, it's still within the NL, UCL, level limit. So we maintain that kind of approach actually because it helps in the cost optimization.
Yes.
Yeah.
Okay, let's answer the question. Okay, because now 4:45, last night I've given you data, and I have teach you how to get the upper limit and lower limit, X double bar, and how to calculate the X bar for each subgroup. So in group of 4, please learn together how to plot the SPC. So in this 15 minutes, can you do that? And can you help me to stop the recording?
Okay.